In Lesson 3.3, we're going to be discussing systems of inequalities, and our objective is to learn how to solve a system of linear inequalities. So if we think back, when we worked with just a single linear inequality, what we would do would be take that graph of that inequality and sketch it. And remember that with inequalities, you wanted to shade because you had the less than, greater than, or less than and equal to. So that's really the same thing we're going to do with these problems. We're going to take each part and we're going to graph it, each different inequality, and graph it and shade. And then the solution to the linear inequalities is going to be the part that gets shaded by both inequalities. So let's look at our first one. We have 2x plus 3. Y is greater than or equal to 2x plus 3. So we're going to start at 3. And then since our slope is 2, we'll go up 2 over 1. And we'll plot a few points here. Now remember, we also have to discuss whether we're going to do this when we connect our lines as a dotted line or as a solid line. Well, since this was an equal to problem, it was greater than or equal to, then we shade with a solid line, or we connect with a solid line. And then we need to decide which side we're going to shade on. So we can either pick our test point, or because this is a greater than or equal to, we should be shading everything above the line. So let's go back and do a test point real quick. And let's say we use the point 0, 0. So if I put in 0 for the x and the y, I get is 0 greater than or equal to 2 times 0 plus 3. Or is 0 greater than or equal to 3, which is false. So the side of the inequality where 0, 0 is at is the wrong side. That does not make the inequality true. So we're going to shade the other side, which would be the part that's above the line. So I want to shade everything over here. Now, if I take the other inequality and graph it, we're going to take y is less than negative 2/3 x minus 1. We'll start at negative 1, and our slope is negative 2/3, so we're going to go down 2 over 3. Now this is just a less than problem, so we can't connect with a solid line, so we want to connect these points with a dashed line, because we're not allowed to be equal to the line. And since it's a less than problem, we want to shade everything that's below that. So let's take that graph and we'll shade everything that's below the line. So that's everything in here. So if we're looking at the system of inequalities, we want the part that's been shaded by both inequalities, and that's going to be the part of the line, or the part that would be located right here. So this would be my solution to that linear system of linear inequalities. Now let's take a moment and sketch another one. So we have 2x minus y is greater than negative 3. Well, the first thing we need to do is solve for y equals. So we're going to subtract a 2x from both sides. Then we'll divide everything by negative 1 and get y is less than, since we divided by negative, we've got to change our inequality, is less than 2x plus 3. So again, let's plot that. Since we are not equal to, when I connect my dots, I want to do a dotted line, or since we are less than that, then we want to shade everything that's below that. So we'll shade everything that's below that line. And again, you can use a test point, but this would be my solution. Now let's look at the second one, which is already ready to graph for us. So let's start at positive 1. And my slope is negative 1/2, so it's down 1/2. Up 1/2. This is an equal to, so we'll connect these dots with a solid line. And it's a greater than, so then we want to shade everything that would be above that line. So let's shade everything in here. And again, the solution is the part of that where those two graphs overlap. So then we're looking for our solution to be this part. So if you can graph simple linear inequalities, then you can graph systems of inequalities. Now let's look at a word problem and try to set up some inequalities to go with these. So your city's cultural center is sponsoring a concert to raise at least $3,000 for the city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type must they sell? So we're just going to look for at least one solution for this because there's actually multiple solutions. So let's look at the fact that we have 500 orchestra seats. So we'll notice that we have two different types of seats, balcony and orchestra. So those are going to become my variables. So let's let X be balcony seats and let Y be orchestra seats. Now we have at most 500 orchestra seats to sell. So we know that Y has to be less than or equal to 500. We may not sell all 500 seats. We also know that we want to raise at least $30,000. So if we take how much we charge for a balcony seat, which is $20, times how many we have, which would be X, and then we add how much we charge for orchestra seats, which would be $30, times how many of those we sell, which would be Y, we want to make at least 30,000. So we want to make it greater than or equal to 30,000. And now let's look at the graph of that. So I used a graphing calculator to go ahead and sketch these. This line here is going to be our Y was less than or equal to 500. And then our second line, so this line should be our inequality that 20x plus 30y is greater than or equal to 30,000. So you can tell that the part we're looking for is the part where they overlap, which would be this area here. So any point that falls in this area is going to be a solution to my inequalities. So let's look in there now and find a point that's in that region. So if we look, we can see that right here is a point that falls within that region, and that is if we let X be 1,000 and let Y be 400. That is not the only solution. We also have another solution here at let X be 1,250 and let Y be 400. Or we could have a solution here where X would be 1,250 and Y could be 300. So we have multiple solutions, and any of those would solve that inequality and make us at least $30,000.